Hello, it is now June 9th of 2024 as I make this video, and I'll be talking about this circuit where I use smaller capacitors, and this one is only 10 microfarads. And I'll be taking the voltage that drops over that through those yellow wires. So I'll make the measurements now. I have to lay this down to use the multimeter, current clamp-on meter, I mean. And it measures 12.6 volts. Now I'll take the current measurements on AC. And it measures 0.19 to 0.2 amps. Yeah, fluctuates a bit from 0.18 to 0.2. Now we'll see what comes out of the wall outlet. Down to 0.06.7. Well, it's a little more than 50% savings, is because 0.1 would be about 50%. Okay, that's pretty good. So I only got the one small capacitor, so I can't add another one. But it doesn't make a big difference when I raise the voltage coming out of the AC voltage divider through those yellow wires. And I'll have to figure out how much wattage I can supply to the load device. Now this transformer is rated at 1 amp coming out of the secondary. I could put a fuse on there on the secondary for 1 amp. And then use a proportion formula to figure out how much amps would go to the load device, and then calculate the watts. So we know how much watts can be used for the load. You can always put a fuse on the load. wires coming out. So I don't know how much current these little capacitors can take. So I might have to use these bigger ones here. So I'll take some work, some calculating to do to figure all that out before I mount it all in this case. Okay, that's all I want to talk about for now. Thank you for watching.